What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to have a look at the difference between distance and displacement when we're talking about physics. This lesson is actually pretty intuitive. The concepts do make sense, but we just need to learn the mathematical language behind the things that we're talking about in order for us to get these questions correct every single time. The first example we're going to have a look at is a swimming pool, right? All I want you to think about is you in the pool doing a couple of laps. If you swim from one side of the pool up to the other side and back, how far have you actually swum? If the pool is 50 meters, we've done 100 meters of work. You would say, yeah, I swam 100 meters, pretty easy. But if I asked you how much have you physically moved from the spot that you started, that would be different. And that's the difference between distance and displacement. So for the distance, we've done 100 meters, but the amount of change in my body from when I started to when I ended is just 0 meters. I've ended up in the exact same place. So the difference between distance and displacement is distance is just the total distance that we went. How far did you actually go? Whereas the displacement is the change in your start and end position. So our distance is incredibly easy to find. It's just repeated addition. How far did you go? Add those numbers together and you're going to find the distance. The displacement's a little bit more conceptual. You might have to use our vectors or our drawings in order to get these correct. We're going to have a look at a couple of examples and I do think you're going to find it quite easy. But knowing the difference between the distance, the total amount you went, and the displacement, the change in your place, is incredibly important for getting these questions correct. So a really easy example is just thinking about like agility tests, right? Let's say we've got 4 cones set up. They're 5 meters up and down and 3 meters across from each other. If you have to run to each cone to prove how agile you are, the distance that you take is incredibly easy. If I'm going from A to B, I've just run 5 meters, easy. If from there I go to A to C and I've got to go the whole way round, I've just done that first 5 meters and then the 3 meters afterwards. Then from A to D, assuming that I've gone the whole way around, I just add on those 5 meters backwards. And then finally to finish, I'm going back home. And so I just have to add those last 3. So the distance from A back to A is just equal to 16 meters, done. But the difference here is if you're looking for the displacement from A to D, it doesn't matter that you've done the big circle on the outside. It just assumes you've taken the shortest path. It's, hey, what's the difference in position between A and D? Write that number down. So the displacement for A to D is just that bottom section, which is equal to 3 meters, and you're done. So the difference here is the important part. So just to hammer this home, displacement is just talking about the change in position from where you started to where you are now. The way that you frame this is how far away am I from home? Where do I need to go in order to get back home to my starting position? It always has a position and a direction. So if you're going east or west, that information is incredibly important. The way that I think about it is how far have I moved from this place? How could I get back there? All you need to know is that it's only taking into account the change in position, not the whole journey that you took to get to that point. So we're going to have a look at an example that's quite fundamentally easy. If we're starting at a point anywhere, right, and I take 3 steps east, all you need to imagine is I'm going 1, 2, 3. I'm now 3 meters east of where I started. From here, I forgot something. I've got to turn around. I now have to take 5 steps west. So from my position, that 3 meters east, I have to take 5 steps to the west. If you ask my total distance, that would be the 3 meters east plus the 5 meters that I went west. So I traveled 8 meters. That's how many steps I actually did. But if you're asking for my final displacement, where did I end up compared to where I started? All you need to know is that I went 2 meters west. If I had to go the quickest direction, instead of going up and then back, I would just take 2 steps west and then I'm in that same spot. So my displacement is 2 meters west, and that's really important. It's got how far, the 2 meters, and it's got a direction. I went west, and that information is incredibly important. So just the overall pro tip is that your final answer, anytime you see the word displacement, you need to know, hey, I need a number and I need a direction. It can be up, it can be down, positive, negative, east, west, whatever. But as long as you've got a number and a direction that tells you where to go, you're definitely going to get these questions right. So we're just going to have a look at 2 really quick examples here. Let's just say I went 30 meters west and then another 40 meters west. I need to find the distance and displacement that I went in this scenario. I'm going to draw out arrows just to really help me out. These vector arrows are incredibly important, and I would highly recommend doing the same when you answer these questions. So to start off, I went 30 meters west. Pretty easy, write that down. Then I stopped and continued in the same direction for another 40 meters. My distance here is pretty simple. I went 30 meters, I went 40 meters, so I did 70 meters in total. You might be thinking, oh, well, the displacement's exactly the same. You just went 70 meters in the same direction, and you would be correct. It's 70 meters still. But I do have to write that I went 70 meters west. That last little bit, the west, is incredibly important. You just won't get a mark if you don't write that down. So just making sure you take the time to think, hey, whereabouts am I actually compared to where I started? That little bit of thought will get you marks in an exam. So in this example, it looks almost exactly the same, but I went 30 meters west and then 40 meters east. Here I would highly recommend drawing out our arrows again, just because it'll give you an understanding of what the answer should be before you even get started. So if I went my 30 meters west and then my 40 meters east, the distance is exactly the same. Hey, I went 30 meters and then I went 40 meters. My total distance covered is 70 meters. But the displacement, the change in my position from where I started to where I ended, doesn't care about all that distance in the middle. It just cares that, hey, I went 30 back to start, and then I went an extra 10 meters. So my displacement for this one is just 10 meters east. So one thing that could help you out with these questions is I want you to assign positive or negative to a direction. So for example, let's just say that left in this example is definitely positive. So if I go 6 centimeters left and then 8 centimeters right, the mathematical equation that I do instead of drawing something out is that I went 6 centimeters left plus 6, definitely. And then plus I went 8 centimeters to the right. Because right in this example is negative, I've gone plus minus 8. Now I just have to throw this into my calculator and find out that I've gone -2 from where I started. Because minus in this example is right, I know that I've gone 2 meters right, and that's all the information you need to put in. Again, I would still throw down the arrows. I love these arrows 100% of the time, but if you don't want to use them, just assign a positive or negative thing to your original directions, and you'll get these right every single time. It's really just basic addition. So I do hope that this lesson's helped you out. If you take anything away, it would just be please use your ruler when you're drawing these arrows, just so you can have a good guess before you even get started. Thanks so much for watching, and I'll see you later.